So now we're back to our original problem. Let's have a go at solving this one. So let's just rewrite it on a new page. It's y, oops, y equals 3x plus 5, 7 over 2 sine cubed 5x. So this is a product of two functions, and I'm going to split it into two parts, a u part and a v part. So let's write these separately. U equals 3x plus 5 to the power 7 over 2. And v equals sine cubed 5x. So this one we'll do du by dx. Bring the power down, 7 over 2. 3x plus 5. Reduce the power by 1. So that's 5 over 2. So 7 over 2 minus 1 is 5 over 2. And then multiply by the derivative of the bracket, which in this case is 3. So that comes out as, well, we can combine the 7 over 2 and the 3. It comes out as 21 over 2. 3x plus 5 to the 5 over 2. So now we do the v. Now I'm going to rewrite this as sine 5x cubed. Okay, because that's what sine cubed 5x is. It's sine 5x all to the power of 3. So dv by dx here. Again, this is a chain rule problem. We bring the power to the front there. Then we reduce the power by 1 to 2. And then multiply by the derivative of sine 5x. Now sine goes to give cos 5x. And of course you bring out the derivative of this thing. So it's the 5 there. And then we can combine the 3 and the 5 to give 15. And then we've got sine 5x all squared times cos 5x. And then what I'm going to do here is I'm just going to return this to sine squared 5x. So 15 sine squared 5x times cos 5x. Now you'll also notice I've missed out the brackets here and here. Now the reason I've done that is because it is understood that, say, when you take cos of something, if it's a single product term, okay, you're going to take cos of that thing there. If it had a plus in it, you would need to put brackets in it. So hopefully you're clear about that. If you're not sure about that, let me know. So now we can apply the product rule. So dy by dx is v du by dx plus u dv by dx. So now I can copy these things in. V is sine cubed 5x. Du by dx is 21 over 2. 3x plus 5 to the power 5 over 2. U is 3x plus 5 to the power 7 over 2. From there, and dv by dx is 15 sine squared 5x, and I'm going to put the cos 5x on the next line below. Now, as you can see, these expressions are getting really long, and it might actually help you for some of these if you turn your sheet of A4 on its side so that you get some length in the page. Otherwise, you'll have to stagger the expression over 2 pages. So the next thing to do is to try and simplify it a bit. So I'm going to move this bit here to the front. I think I've said before that you tend to put numbers first, so 21 over 2, then powers, so 3x plus 5 over 2, and then the wordy functions like sine, cos, and ln and stuff like that at the end. So sine cubed 5x plus 15 3x plus 5, so 7 over 2 sine squared 5x cos 5x. So I put the 15 first, the number first, then the powers, then the wordy functions. So now I'm going to tidy this up, try and factorize it out a bit. So first of all, I'm going to take out, so I've got various things I can take out. I've got number there, I've got a power here, and I've also got signs here. So I've got lots of scope for factorizing. I think what I'll do is I'll start with this thing here. So I'm going to divide that entire expression using the method that we talked about earlier. I'm going to divide the entire thing by the smaller of these two factors. That's the one with the lower power, and it's 15 over 2, because 5 over 2. 5 over 2 is 2.5. 7 over 2 is 3.5, so I'm going to divide the whole lot by 3x plus 5 to the 5 over 2, but I'm also going to multiply by it at the front to compensate. So let's do that. So I'm going to write 3x plus 5 to the 5 over 2, so that's this thing here. Then I'll put square brackets in, just extend the page a bit. Then 21 over 2 sine cubed 5x plus 15. Now I then come to the point where I want to divide this by 5 over 2, because I've divided that by 3x plus 5, so 5 over 2, and it's left 1, so it's disappeared from here. Here I'm going to divide 3x plus 5 to the 7 over 2 by 3x plus 5 to the 5 over 2. So that's going to give me 3x plus 5 to the 7 over 2 minus 5 over 2. Now that works out as 1. 7 over 2 minus 5 over 2 is 2 over 2, which is 1. So I'm just going to erase that, and I could write 1 there, but I'm not going to, because by default, when you have a power of 1, you don't write the power. And then we've got sine squared 5x times cos 5x. Will I make it on the board? Yes. So the next one I'm going to take out, I'll do some green here, is the sine. So there's sine cubed of 5x and sine squared of 5x, so we're going to take out the smaller of these two factors. I'm going to divide the whole lot by sine squared 5x, as long as I multiply, sorry, I've made a bit of a mess of that. Let's get rid of that. Okay, I'm going to multiply that by sine squared 5x to compensate. So that'll give me 3x plus 5 to the 5 over 2 times sine squared 5x. And then 21 over 2. Now sine cubed 5x over sine squared 5x is just sine 5x. Okay, so we've done power of 3 minus power of 2 is power of 1. And then we've got plus 15, 3x plus 5 sine squared 5x over sine squared 5x is just 1, so the only term left is cos 5x. Now we're nearly there. What we're going to do now is take out some numbers. Now the first thing I'm going to do is I'm going to eliminate that fraction. See, I've got 21 over 2 there. I can take the over 2 outside, and that'll make the rest of my factors clearer. I'm going to multiply that whole expression by 2 as long as I divide that by 2 to compensate. And what that'll do is it'll have the effect of taking this fraction to the front. So instead of writing divide by 2 here, I'm going to do multiply by a half. So here, I multiply that by 2 and I get 21. And then here I multiply that by 2 and I get 30. So what can I do now? Well, there's a common factor in here. I can see that 30 and 21 share a common factor. And the common factor is 3. So what I'm going to do is something purple here. I'm going to divide all of that by 3 and multiply that by 3 to compensate. So 3 times a half is 3 over 2. 3x plus 5 to the 5 over 2. Sine squared 5x. And then here, 21 divided by 3 is 7. Sine 5x, and 30 divided by 3 is 10. And that's it done. And that's it complete. Now I could write these terms in a slightly different order, but that's effectively it done. So just one more thing. The original problem, if we go back up to the top, it's not even on this page, it's on the previous page. That was quoted as the square root of 3x plus 5 to the power 7. So it probably makes sense to come back down here and reconvert that. And make that the square root of 3x plus 5 to the power of 5. I certainly wouldn't be penalising you in an assessment situation for not doing that, but it is conventional.